Let us look at the volume of a prism. First we have to ask ourselves, what is a prism? Well, the most typical prism is a triangular prism, like a Toblerone valve, or it's kind of tent shape. Triangular, because obviously it has a triangle as a front face. Now if we were to cut through the shape, we should have that exact same triangle running all the way through it. And that's what defines a prism. It has the same front shape running all the way through it. Take a cylinder. If you cut a cylinder, you should always have that same circle all the way through it. It doesn't have to be a regular shape. You know, here we've got just a block, but we can extend it out into 3 dimensions. It should still have that same S shape running all the way through it. Now to find the volume of a prism, it's pretty easy. If you can get the area of the front face, you just times it by how far back it goes. In some cases you might know the area of the front face, in other situations you may have to calculate it. We're going to have a look at a couple of examples. We're going to have a triangular prism. It's going to be with a right angle triangle. And these are going to be our dimensions. Let's put them in centimetres. Well, the area of a triangle is half the base times the height. Now the base is 4, the height is 6. So it's a half times 4 times 6. Doesn't matter what order you do this in. Essentially, I usually do 4 times 6 is 24, half my answer, 12. We're after the volume, multiply it by how far back it goes. So times 10 for the volume. And we have 120 centimetres cubed. Notice how the unit has gone from area to volume. Let's have a look at a more awkward shape. This is going to be a trapezium. It has a top side of 6, a base of 10, a vertical height of 5, and it goes back 8. Now to find the area of a trapezium, you basically average out its lengths and multiply it by the height. If you add together 6 and 10, you get 16. And if you halve that, you have averaged out the length. So the average length is 8. 8 times 5 is 40. That's the area of the trapezium. Now we multiply it by 8. And we should have the volume of our prism. We're going to have a look at how you the surface area of a sphere. So that's essentially a 3-dimensional circle, or in other words, ball. Now just like 2D circles, it's dependent on the radius and that's for both formula. Now you wouldn't normally have to remember these formula, so just knowing how to use them is a step in the right direction. You have to remember that when things are together, it just means you multiply. If something is squared, you multiply it by itself. If something is cubed, you multiply it by itself 3 times. Let's have a look at an example. Circle. I'll try my best to make it look a little 3D. So if you picture that as a ball, the radius would come from directly in the centre of that ball to the outside edge. In my example, the radius is going to be 6 centimetres. Let's calculate the volume to start with. So the formula is 4 over 3 pi r cubed. 4 over 3, what you can do is just times it by 4, divide it by 3. And it doesn't matter when you do that. Pi is just a number. If you don't know it, you can use 3.14, or if you have a scientific calculator, it should actually have a pi button on it. I'm going to use the pi button because it's more accurate. So let's have a look at doing this. Basically I have 4 times pi times the radius cubed, so that's 6 times 6 times 6. And also just remember to divide by 3. Doesn't matter what order you do any of this in. 4 times pi times 6 cubed divided by 3. You're going to get a large answer. That's quite normal for volume. (904.8 centimetres cubed). As I say, quite normal to get a large answer. The surface area, this is going to be even easier because it's just 4 times pi times the radius squared, 6 times 6. So the surface area, 4 times pi times 6 squared. Should hopefully be a slightly smaller answer this one, so 4 times pi times 6 squared, 452.4. That's an area. Let's have a look at finding the area of a cone. These are the formula as they would be given to you, and you may also be given a little diagram. Now this diagram is important because you need to distinguish particularly between H and L. So a cone, just like the circular pyramid. The radius, as with all circles, would be from the centre to the outside. So if you picture the middle of that circle underneath, the distance from the centre to the outside. H is the height of the cone. Now it has to be the vertical height. So going from the bottom of the cone straight up to the top. Now L is how long the slanting side is. And that's important because the angle at which that's sloping will affect the curved surface area. Now we'll have a look at calculating both of these things for an example cone. I'll redraw the diagram but give us some numbers to work with. Again, we'll deal with centimetres here. Okay, this should be all we need to know. We've got the radius, the sloping edge, and vertical height. We'll do the volume to start with. 1/3 pi r squared h. We can treat 1/3 as just dividing by 3. Pi, we know to just be a number. R squared, so it's got to be 4 times 4, and h, the vertical height. So the volume, it becomes pi. You can use 3.14, that's fine. R squared, so that's 4 times 4, times h, times 6, and divide by 3 for that third. Okay, again, it doesn't matter that much when you do what order you do these in, as long as you do it all. So let's run to the calculator because we're using pi. I'm just going to use the pi button. I get a solution of just over 100. So volume, so that's centimetres cubed. Now the curved surface area is the surface area of the shape, but it doesn't include the circle at the bottom. So if you picture rolling out a cone, it would just be the area that wraps around the slanting side. So that's what we're going to do now. Curved surface area. The formula is much more simple. It's just pi times r, so that's the radius, times L, the slanting side, so just times 8. Again, I just use the calculator. I'm going to use the pi button. Now we get exactly the same answer here. The reason is, and now this doesn't always work out this way, if we just have a look at the numbers. If you divide 6 by 3, that would give you 2. 2 times 4 is 8, so we've got 4 times 8, and that's the same as what we've got here. So it's just by complete coincidence, this area is the same as this volume. Other numbers, it wouldn't work out that way.